Hi everyone. In this video, I'm going to explain how I actually solved the September Jane Street puzzle here. And I'm going to show you the code that I used to write it and kind of my thought process going through it. So the first thing is that I looked at it and I tried to do it by pen and paper initially. And then I kind of realized that that wasn't a very good strategy. So my first idea was basically to look at it and then I would write code to fill in some of the rules just to get an insight into how the solution actually looked. But what I ended up doing is basically solving the entire thing using code. So how I approach this is basically first thing I did is I wrote down the rules. So it's a 9 by 9 grid. You have your given numbers. You have no filled 2 by 2 squares, not 4 by 4. So next one, there must be 9 9s, 8 8s, 7 7s. They must appear in these hook shapes, which you can see here, kind of circling around. And all the nines must appear in one hook, all the eights must appear in another hook. Um, from the side and from the columns, obviously certain numbers like 3 must appear first in this column, looking from the bottom. 6 must appear. So I looked at that rule, and I just kind of broke down all the different rules. The shape ones were by far the most difficult to put in. They almost fulfill these pentomino. Please let me know if that's the correct pronunciation. Shapes. Um, these pentomino shapes must appear at least or at most once. All the numbers in the pentomino shapes must appear. Must be like some of them must be a multiple of 5, and the last one, which I almost missed, was that all the squares must form a connected region. So the first thing I did when I looked at this is I noticed this is hooks 11, which means there is 10 questions like this one before. So I just looked on the internet, looked up a few previous solutions, and I found this by Go and 10. So I'd like to thank him. He basically did the solution for hooks 10, and that was super handy because it I basically ripped or copied his logic for the hooks, and so that saved me a lot of time. See, he's already got the logic coded in. So I already had some of the logic that I could copy and paste for the hook, so that was super helpful. Then I added in, of course, the no 2 by 2 squares must be filled. I added that in myself. And this is basically an exact copy of what Go and 100 did, so it's kind of not much to copy there. Then this was specifying, okay, in column 2, we can see the 3 must appear. And then if we go back to the actual shape, in the second column, looking from the bottom, a 2 must appear. So I basically followed that logic to add in all of these numbers. And then finally, the most difficult part was the shape split. So I wrote them all down, like how they would look. I created an index just because it's easier to read. Then one thing that was tricky is that you could rotate, you could reflect it, you could normalize, or you could have, and then here you can do any sort of unique transformation of them. So this is what I did is basically took all the shapes and I created their unique transform. Then here I basically created a registry where I took the variable, I gave each shape a shape ID, the norm of the shape or the normalization of the shape, and then these are the indexes that we want it to appear, the cells it occupies, and then I append this. So I have a bunch of lists of all the possible places that our shapes could be. And then here, I made sure that in a singular block, you can only have one shape. And I made sure that no shapes can repeat. So you can't have multiple Zs. And that was basically how I created the logic the um, for the shapes appearing once and not repeating themselves. And then the second part was to make sure that, say, the Z, which is up here, or down here, of course, was the first one seen on this row. So I got the Z ID, and then I copy and pasted and then I made this constraint that it must be the first one seen looking from the left at the bottom. And then I did the same for the I on the very tippity top. And then on the other side, I made sure that the V was the first one to be seen from this side, same with the X and same with the U. Then I was very lucky that I actually used this constraint, and this was kind of my attempt to make sure that the sum of all the numbers in each shape added to a multiple of 5. But I found that quite computationally inefficient to do. So I kind of got rid of it and thought, okay, I'll just add it in the end. But it turns out that the solution that the solver came up with actually didn't need it. It just automatically had this constraint. It just by sheer chance fulfilled this constraint. So I didn't actually need to add it. I just verified that it was true. And then the final one, which I almost missed, was that the filled squares must form a connected region. And this is what all this code does. And finally, once I'd gotten all this, I just some plotting functions, and then I used the solver, and it came up with this solution. And then, of course, I verified it, and that was how I solved it. That's what it looks like with the numbers. Anyway, thank you for watching. That was how I solved the September Jane Street puzzle. I'll link the source code that I used in case it's helpful for anyone else in the next Hooks puzzle. And thank you for watching.